Okay. All right. So what we're going to do is I've got some basic commands, and what the goal of these sessions here is going to show you how to navigate Linux. The only thing I could tell you is just like SQL, if you don't practice it, it's going to be an issue later on. You start, well, you'll remember it. You're going to lose it, and you got to figure out how to remember certain things. And I'm going to show you what I do when I forget how to do some items. I've got some sections here, you know, and I'll post these on the Unix for you as we go through them. But basically, the whole idea is to learn how to navigate through Linux, learn how to navigate through the files, what some of the basic things are. And then what we're going to do towards the end, I want to actually show you how you can take one piece or two pieces of code like R or Python, run it so that you can run it in the background and you can leave your computer and it's not taking up all of your foreground. Like you run R in RStudio and you're stuck. Well, you can run it as a process and continue using R to do other things. Okay. Oh. So there are ways to run items in the background where it'll just run and run and run and give you the information when it's done. But it requires us to understand some of the basic stuff of Linux first. Does that make sense? Now, you guys are on a Mac. I'm going to use the Mac terminal, which is what's called BSD Unix, which is Berkeley Software Development. So it's at the University of California, Berkeley. Now, a lot of it is the same, but there are certain little things that are nuanced, and I'll show you how we figure out how to navigate through some of that. So the first thing here is I've got my terminal window, and I'm going to have a couple of commands. So when you log in, it obviously is going to begin to tell you what your machine name is. This is your what's called your home directory. So in all versions of Linux that I know of, the tilde is the home directory, and that's kind of like when you log in as a user, you get a home directory. If you have a Linux as a server, you have 7 or 8 or 9 people who can log into the machine. They each get their home directory. And you have the same thing in Windows as well, but this is where it came from. So the first one that we're going to do is this thing called uname, which is basic information. I want to know about my system. Now, when we run a command, there are some parameters that come after it, like -A and -R. So -A gives you the system information. The -R gives you kernel, and the kernel is what the core operating system is. It gives you a little bit of detailed information. So this is what it looks like. We'll type the words uname, and it says, okay, the name of the system is Darwin. Okay, that's the name of the version of the Linux. Like if you remember from R, it is I forgot what they call, like Shady Tree or something like that. If you do uname dash, I think it was A, you'll see I get a lot more information. I get the name of my machine. It's running this Darwin kernel version 18.6, what today's date is, here Pacific Daylight Time. I don't know why it's saying that. So I can check that actually. And here's my root kernel. So this is some kernel information that I have. Now you wouldn't need any of this in general, but it's available to the uname function. The other one I think was R. Uname-R. Okay, and here's basically my 18.6. So that's the version that I have of this Berkeley Software Development. All right, so now the next one, which actually I wasn't prepared to do this on the Mac, so I got to see exactly how this works. I'm going to try the cat, but I don't remember what it is. Actually, you know what? Let me come back to this one, because I don't do it on the Mac that often. There's no need to, because we can get it directly from the GUI. I'm going to jump to hostname. So this is the name of my machine, MacBook Pro 5 .local. So it just gives me the name, nothing else. Don't need anything beyond that. But now I may want to get the IP address. So I will do hostname-I. And that is not legal on the Mac, but this is ifconfig. And you can see ifconfig gives me everything that I need about all of my drivers. The L0, which is the local host, it's a loopback, so it's 127.0.0.1 if you remember that from any of your other classes. If you look down, this is my IP address on my local box. This is my Ethernet card, EN0, and this is the internet address, 192.168.1.151. If you had multiple cards doing different things, you would have multiple pieces of information here. But that's how we find our that's how we find the information for the address. Now, you'll notice that when I typed in hostname, I'm going to type clear, which will clear my screen. And I type hostname, and remember I just did -I, and it said illegal option. Because it says I only, on the Mac here, I only have two options, the F and the S. So if I do hostname -F, that's the actual name. And if I do hostname -S, that's the same one. On the Mac, it doesn't give me much options. Let me try FS to see what happens. Yeah, I'm not sure why it's not giving me the anything else. On a Linux box, if you do the -I, it will give you the IP address on Ubuntu. I don't know about Red Hat, to be honest with you. Okay?
Mm-hmm.
That's one of the problems with this, is that the different versions are slightly different. So let's try uptime, which should give us how long the system has been running, date, and who am I. Some basic items. So uptime, I don't think that works here. No, it does. So this basically says it's been up 1 hour, 26 minutes. This is the current time, 22:12. Basically, I've had 2 users on here, and it gives me the load averages, just telling me how much load CPU they're actually taking. Nothing more than that. Date gives me the date, and who am I? And that's who I am currently logged in as. Okay? Does that make sense? You have some basic commands there. Now, the bigger part, it gets to these things, which is the directory and file commands. So we've been running a few commands. Now I want to do some little deeper items with regards to the directory. Now this is probably the biggest thing that you will do. So we'll make sure we spend some time on that. So I'm going to clear again my screen. And now I'm currently in the tilde directory. So what I'm going to do is I'm going to type pwd first, which is down on the list that I have. pwd tells me the current working directory that I'm at, which is this users Alex Polize. Okay? So you ever say, well, what directory I'm in? That's the directory I'm in. However, if I type ls, it will give me all of the files and directories in my current, in where I currently am. So you see I got my videos, I've got ANOVA 2A, I've got PSOLI, Raspberry attendance, etc. But what it doesn't do is it doesn't tell you exactly whether they're files or whether they're directories. So the ls command allows us to expand a little bit of that. If I do ls-l, it will give me everything in a list. Here's my file. Here's the date last modified. Here's how big it is. These 2 items, I'm going backwards for a reason, are who's the owner and what group they are located in. So we're going to deal with users and groups a little bit later, but suffice it to say, every login account is a user. You can put them in a group so that you don't have to give access to like a single individual. You can give access to a group of people. So you can shut people off from certain directories. For those of you who've had problems on the Mac with MySQL, with the load data in file, this is exactly what's happening. MySQL is the owner, and MySQL is the group. So the only way to access a particular directory is using the MySQL ID, which is created when you install MySQL. Over here, we actually have we have what's called the file settings. So, and I'll go through this a little bit later today as well, but the important part here is that first one with a D is a directory. Okay? First one with a D is directory. The other 3, the other sets I'll explain afterwards. All right. So now what we'll do is we'll do a make directory, and then we'll start removing some files. I got to find files that I can remove, though. I don't want to kill anything. That's good. Okay. So what we're going to do is I'm going to make a new directory called Linux class. Now, if I do my ls-l, I should see here in order Here it is, Linux class. You're going to notice the order of these is capital comes first, then it goes into the lowercase. Okay, everybody see that? And here's your directory. That's how you know it's a directory. Now, if I want to go into that directory, I'm going to do cd linux class. You'll notice that now my directory here has changed. It says it is in Linux class.
Hi, Alex.
Yep.
I'm sorry, we can't see. At least I can't see. You need to scroll down. Okay, thanks.
Okay. I'm still at the bottom. There's not much I can do. Well, actually, what I could do is this. Hold on. Let me do this. Is that okay still?
Yeah, that's good. Much
Okay.
better.
So I'm going to clear this again. I'm still in the Linux class. I type pwd, and it tells me you're in the users Alex Bly's Linux class folder. Okay. If I do an ls inside this folder, -l, there's actually nothing in here. Sometimes you will actually see, if you do ls-al, you'll see commands like on the internet says do al. Well, what al does is it gives me all files. Every directory has two directories in it, the dot and the dot dot. What those are, they are references to the current directory, which is a dot, and dot dot is the parent directory. So if I want to move from Linux class to the parent directory where I was, I could type cd ... and it will take me to the parent directory. The dot is the current directory. Now you say, well, why do I need to change directory to the current directory? You actually don't, but it's kind of needed for when you run scripts in a current directory. You don't run it directly, you actually run it with a dot and then the actual name of the script. So we're going to do scripts at the end of this whole thing, so I could show you how to write a script, and then you're going to see that you kind of need to use the dot in that case. Okay. Any questions so far? Okay. So now what we're going to do is we're going to look to remove a file. I'm going to actually create one first, and then we'll take care of that. So let's go back into the Linux class. And I'm going to use a local editor, which I'll show you as well at some point. Nano poetry.txt. I think I can do this. Nope. Darn it. Okay, so I had copied something from Shakespeare, but take care of that later. I'm going to create some files. Some lines. This is a nice haiku if you're not familiar with it. Chris showed me this haiku. Save it. Okay. Now you'll see the file poetry.txt has been created here. Okay. So now what we want to do is, instead of me moving it first, I'm going to copy it. So let's say I want to make a copy of the file. I'm going to use this cp command. I'm going to come back to the remove so I can get rid of it later. I'm going to make a copy of the file. So the copy command is cp, the name of the file, and what we're going to copy it to. Okay, so I'm just going to type cp. Since the file is called poetry.txt, I'm going to copy it to poetry2.txt. When I list it, you'll see the two files are there. Okay. Now, if I want to copy everything from this directory into another directory, so what I might do is, if I've got this Linux class, I'm going to come back to my parent directory. I'm going to create another directory using make directory, call it Linux class 2. Now what I'm going to do is I'm going to copy everything in Linux class to Linux class 2. Now this should give me a problem. Okay. Now the reason it's going to give me a problem is because when you copy directories, where is it? You need to use this -r. The reason you need the -r is because it has to go recursively through the directory. It literally has to go through each directory, make sure there's no other directories, and copy everything that's there. So I'm going to put the -r. Now you'll see it doesn't give me a response, which is what I want. I'm going to go into Linux class 2, list, and there's my file. It copied Linux class, it copied the whole directory into Linux class 2. So you go to Linux class, and you'll see that's the files are in there. So it took Linux class and the directory and the files and put that directory, made a copy into Linux class 2. Does that make sense? You go with that? All right, now let's say I wanted to actually copy everything inside of Linux class, but not copy it as a full directory. Well, I can do that. Instead of copying recursively, I'm going to put after it star. In other words, I want you to go to the Linux class directory and take every file and make a copy of it and put it directly into Linux class 2. Of course, I can't find it because I'm in the wrong directory. There we go. I had to be in the root directory because Linux class and Linux class 2 were both in that directory. So now if I go to Linux class 2, you'll see it now copy the 2 files, poetry, into itself. And I still have the Linux class directory from there before. Okay? Does that make sense?
Yes.
Okay. All right. Sorry. Let's go back here. All right. So what do we got now? I'm going to remove. So we're going to remove it. So now what I want to do is I want to remove a file. So if I want to remove poetry 2 from this directory, Linux class 2, I'm going to do remove poetry 2.txt. List. And you can see that the directory, that the file is gone. I want to remove the other one, poetry.txt, and now that's gone as well. Okay? Now, what if I want to remove the entire directory Linux class? So I'm going to do rm-r because I need to do everything recursively, and then the name of the directory, Linux class. Now, if you list, you'll see that it's gone. That is no longer there. So that's how we move directories. I want to warn you about this, the star. If you do star, it removes everything from the current directory. If you run that as a super user, okay, now the super user is a protected user. It's like the super user can do anything. It's a full system administrator. If you do that on your root directory, you will blow away your whole computer. Okay? And the reason I say this is because I had someone do that on our server. He accidentally did sudo for a super user, and I'll show you that later, rm star, and he was in the root directory when he did it. He did not realize where he was when he did it. And so it wiped out our whole server. So you really need to be careful because Linux is not forgiving. Unlike Windows, where it prevents you from doing certain things and it gives you prompts, and Mac does it too, when you are in Unix and you're in this terminal line, it is not forgiving. You screw up, you screw up. Okay? You hear me on that one, Chris?
Were you able to recover the stuff?
Huh?
Were you able to recover the stuff you got rid of?
There were ways to recover it. I could not recover everything, so I had to rebuild it.
Okay.
And it was horrible.
Sounds like it.
It took me about a week and a half to get it to a point where we just literally rebuilt it, and it took me a day to rebuild it with all the data and everything else. Okay. All right, so that takes care of, now let's talk about moving. Let's say I want to move a file, which is really nothing more than renaming. So if I go, let's say I want to go back here. Let me clear this. I'm going to show you something else on this ls. So let's say with ls, I want to look for everything that begins with Linux. I'll put a star after the word Linux. Oops, let's see. Oh, because I got to go back. And it will show you every directory that begins with the word Linux and anything inside of it. So I have 2. I have the Linux class and I have the Linux class 2. So I want to remove that Linux class 2 directory, Linux class 2, And now that should be gone. And so all I'm left with is these two poetry. They're basically inside of the poetry items. So let's go back to Linux class. And there they are. Okay. Now, I want to change the name of poetry 2 to poetry like 6. So there is no like change file. You have to do mv for move. So we do mv poetry2.txt, and we'll call it poetry6.txt. Now you'll see it's renamed it to poetry 6. Okay. Any questions? No? Moving right along. Now, this command cat is going to show us the contents of a file. So this is good when you have some small files or log files that you want to see. So like if you've written R code and it puts output, you know, like print something, like print where you are, the time, and so forth, you could output that to a file. So what we could do is we could do cat poetry6.txt, and you'll see it gives us the file. Literally just displays it on the terminal, nothing else. Similarly, now if you have a very large file, it's just gonna scroll right off the screen, and then you gotta scroll up, so it's not as straightforward. What we could do, and let me see if I have a larger file to show you this. Survival.r. Nope, that's not long enough. I need a long file. That's too big. That's too big. Let's do this one. Query. Can't see. Query reports 42.
Sounds like Kiwi's killing something back there.
Just all of a sudden, she was sleeping until I started this call, and now she wants to play. Perfect. Okay, so this is a file. You can see it's a fairly large file, right? And so if when you do the cat, you see this whole thing. So what I can do is I could do more. I'm just gonna. I did the up arrow, by the way, so it gives me the last command. Now, what it does is it starts the file. It's loaded the file into memory, and it's shown me the first set of lines up until my screen can't handle it anymore. When you hit a key, any key, it gives you the next set of lines and it'll loop through this whole process until you get to the end of the file. You're going to notice down here, there's a colon. It's waiting for a command. When you type Q, it's done. It says you're saying quit. I've finished. That's how you get that whole part of the file. What you can do is you can do a similar command called less. And it does the exact same thing. The only difference is it doesn't load everything into memory right away. It actually has to go back and get the next set. That's all it does. Now, another one is, again, if you have a large log file, you can actually do something that would be, let's do head RTF, or head of this file, RTF. Notice how, let me clear this. It only gave me 10 lines, which is great. You got a file, you only want to see the top 10 lines, you just use head, and you'll get the top 10 lines. You may want to do only the first 6 lines, so you do -N6. And it will give you only the first 6 lines. Okay? Now, what you can also do is you could say, you know what, I want -6. Illegal count. Actually, it's not here. It won't give me this. On a Ubuntu, you could do -6. It'll give you the last set of lines. But on this, we could use tail. Tail will give me the last 10 lines. And if I do the -N with tail 6, I will get the last 6 lines. Okay? That make sense? Okay, so now I'm going to go back to my Linux class. Here are my two files. The last thing I'm going to do for this piece is I'm going to create what's called a symbolic link. Now, this is nothing more like on Windows. I forgot what it's called, a shortcut. You know how you create a shortcut on Windows which points to another file? That's what a symbolic link is. So what I'm going to do is I'm going to create a new symbolic link. I'm going to do ln-s, and it's basically going to be in this directory, poetry6.txt, and I'm going to give this shortcut a name. So we'll call this hofstra.txt. When you do an ls-l, you will see Hofstra text is the name of the file, which points to poetry6.txt. Okay, so now if I were to do cat of Hofstra.txt, it will actually give me what's in poetry6.txt. Symbolic links are great when you have configuration files or data files that are in multiple areas or in another area, and you want to streamline how they have access to them. That's what these shortcuts do. It just makes it easier, allows you to put things in certain places, like in a directory where everything is, and have it point to a series of directories. Okay, does that make sense? All right, everybody's got this. You're all Linux experts now. Okay, so now what I'm going to do is I'm going to come up to these file permissions. When you list a directory, list items in a directory, you're going to see these things here in this corner, this LR. This L means a symbolic link. The first three here are the user rights. This is group rights, and this is what we call world or everyone rights. So we're talking about restricting the file as to who can either read, write, or execute. Now, the way this works is this. These are binary numbers. So when we have a permission, if they're all ones, the first digit is 1 to the 4th power, the next digit is 1 to the 2nd power, and the next digit is 1 to the 0th power, or 1. So you're going to end up with 4, 2, and 1. Oh, sorry, this is wrong. 1, I don't know what I was thinking. 1 to the 1 power. So this is 4, 2, and 1 because they're all on. So 1 to the 4th, 1 to the 2nd, 1 to the 1. So 1, 1, 1 is basically going to be full access for whichever group I'm doing, a user, a group, or the world. 0, 1, 0 would look like this and would give me basically a 2. And 1, 0, 0 would give me a 4 because the 4 is turned on. 0, 0, 1 obviously would give me just a 1. So when you add them together, if you had another one that looked like this, we put them together, I'll do 1, 0, 1. This would be 1 to the 4th, 0 to the 2nd, 1 to the 1. You put this together and you end up with 5, which basically is read and execute only. Okay? Does that make sense? So when you see the groups here, the first group is the user, the next group is the group, and the next one is for the world or everyone. Remember, on the list here, this is my user or creator. That's who owns the file. This is the group of people. So if any user is in the staff group, they will have whatever is related to the group access, which in this case is only read and execute. And everybody in the planet who has access to the system, regardless of if they're in that group, also has read and execute. And so this is what people do with like web files. They make sure that they're executable because it's a PHP code or a Python code or something else, and that they can read it, but not necessarily write to it. Only certain people should have write access.
Is everybody just put into staff default?
It depends on your system, okay? So on the Mac, I believe it's a staff group, right? So you have staff, but on Ubuntu, there is no staff.
Okay.
Okay? So what we can do is we can change the permissions. So by using this chmod, but I have to give it a number. So let's say I want my user to have read, write, execute, and I want the groups to have read, execute, and I want the world to have read, execute. I would use 755. So this corresponds to 7, this corresponds to 5, and this corresponds to 5. So what we do is we come over to our command line and we'll do change mod 755 poetry.txt. When you do that, you can now see that it changed from this to this. And so now everybody has the ability to execute and read, but only the user has the ability to write, the current user, or the owner, I'm sorry. Does that make sense?
Yes.
One of the most dangerous ones
Don't trust them.
is this one. Because you've now given everybody full access to the file. Okay? And so this is basically the way that works. And so you have, when it displays it, R is for read, W is write, X is execute, hyphen is no access or not applicable, and then D is directory, and the other one I should add here, L is for a link, symbolic, okay, or shortcut. Okay, does that make sense? Now the fun stuff. Okay, that's how you navigate in and out of these directories. Okay, so the next one we've got is going to be dealing with processes. How do I know what's running on my system? Well, I can type this command called PS. Let me clear my system. And you're going to see, well, right now it says you only have one thing running. Now, when I run the PS command, PS stands for process. When I run the PS command, all it's doing is telling me what processes I am currently running, nothing else. So if I were to run a piece of R code, right, it would basically tell me, and this is only within the terminal. So I may have Microsoft Word running, I may have something else running that's on the desktop. That is not part of, when I run PS, this is only for my current session that I'm logged in terminal. But I can type ps-aux. There we go. All right, on the Mac, by the way, let me just show you this. On the Mac and on BSD Unix, yeah, all BSD Unix is not going to have the hyphen. On Ubuntu, you need the hyphen. Okay. Now what this does is this basically, the A is giving me all process. E is something similar, by the way. You'll see this EF. They're for all processes too. I don't know why one is called E and the other A. That I don't know. Basically what we have here is, this is every single process that is running on my computer. Every one. So here you see the first one is Zoom. Okay. The important part of what it's doing is it's ordering it by CPU and memory. So it's telling me how much CPU at the moment I ran this, it was taking. Now, some of you may have had processes that you know, you get the little spinny ball and you go up to the Apple menu and you go to force quit. Well, guess what? What it's doing is it's going to look at this process and it's going to kill a particular process. I'm going to try and kill one, but I'm not really sure which one I can kill, to be honest with you. I got to find one, but I'll show you that in a minute. Every process that's running is given a PID for process ID. That is the thing that you need to know, and that's usually what you're looking for. So let's say you're running an R code. It's like we have some systems that are basically running 7 R code and 3 Python codes in the background, and they just run. And you know, they'll go to sleep, and then they'll run later, and then they'll go to sleep, and then they'll go later, etc. So what will happen is that sometimes it gets stuck. So we want to kill it. I need to know what the PID is in order to kill it properly. So what we can also do is we can find particular processes. There's a command here called grep. What grep does is grep literally finds an expression. This, with the bar, allows us to combine 2 different commands. So what I'm going to do is I'm going to basically say I want to look for something down here. Let's see. Messages. You know what? I can do this one because I can kill. If I kill messages, it's a problem. What can I run here that I can? Oh, you know what? Let's do this. Let's run R. Okay, so I'm running the R console. So this should be another process that's run. So now what I'm going to do is I'm going to go PSAUX. And now I'm looking for R. I'm looking for R. I got to find it. It should be somewhere. Actually, let me clear this and run this again. At the top. And if you run this on your computer, you'll see a ton of things that are running too. Okay, so I have no idea where it is. R may not have been a good choice because everything has an R in it. I'm looking for R. Let me see. All right, since I can't find it right away, I'll do TunnelBlick. TunnelBlick is a VPN, so I'm going to basically search for it. So what I'm going to do is I'm going to run this process. I want to do ps-ef because this is basically all processes. Pipe, which means send the output into this and look for whatever this process one name is, which is going to be TunnelBlick. So we're going to do ps-aux or ef. I'll do the AUX because I forgot I'm on a Mac. Rep TunnelBlick. And you'll see what it did was it actually ran the PSAUX and it literally told me that TunnelBlick is process 599. Now you're going to see there's another process called grep TunnelBlick. Well, that's because when PS was running, it was also running the grep, and that's why it came up and said, you're also running something called grep TunnelBlick, which is, again, you asked for it to look for it, it found it, and so forth. Let me see if I can find R. It's going to give me a lot of stuff. Can I find the R? Because then I can just kill it. That's what I call something else. Assistance. Oh, here it is. Oh, no, it's grep R. All right, I'm sorry. I don't know exactly where it is, and I forgot what it's going to be called, so I'm not going to worry too much about it. I'm going to kill this. I'll run this. Again, you have to know what certain things are called, or at least have an idea so that you can find that R is not really the best. Let me try RStudio. We'll run RStudio. That'll run nicely. So let's see. I think I can do this. There we go. So it finds the RStudio, and basically, well, let me clear this again. And you will see here that it's basically running. Where is it? Library framework. Okay, this is actually R itself. And there's probably an RStudio session somewhere in here. And here's the RStudio. So it found RStudio for us. So now what happens is this. I basically want to kill RStudio. So we have a command called kill. And by the way, if you ever think about this, computer science and computer people, they're not shy. They want something dead. They just call it kill. No, nice process, go down. No, kill. So we're going to do kill. And we're going to do, the process ID here is 2036. So I'm going to do kill 2036. With any luck, it does that. So I will look for my RStudio, and you will see it's gone. And you'll notice down here that RStudio has been shut off. This is a command line way of getting rid of anything, and usually you have better control because the graphical user interface takes up a lot of time. Let me explain also one other thing that's important about this. If you're going to be running high-end data science servers, or you're going to be doing major things, you don't want a graphical user interface on that computer. Does anybody know why? This hurts. I'm upset.
Well, it will take too much time.
It takes a lot of time.
Yep.
It takes memory, and it takes CPU.
Yep.
Okay? And so you don't want anything interfering with the processing required to make sure that you get your data science piece run. So when we have a data science server in our office and we installed Ubuntu, one of the people said, should we install the desktop? No, you do not install the desktop. You do not want any graphical interface. You only want to do things through the command line. Does that make sense, everyone? Hope so. Now, if you want to see real time what's going on, not just type that PS AUX, I type top. And this is going to give me an actual image of what's going on. So I have 373 processes. I'm using about 5.5% average, 7% average of CPU. Let's see, shared memory is 389 meg residence, 69 meg data. I'm not sure what the linked it is. Some of these I don't know because we don't use them all the time. 11 gig is used on my memory. That's upsetting. My disk space gives me 383 out of 399 meg read. So this is the number of bytes that are IO that's going back and forth. And this tells you the command that's currently running and how much CPU. So what we do is we want to look for something that's running. So I'll give you an example. Gabrielle, remember when your Mac was like the fan was going crazy?
Yes.
Okay. You type top and you can figure out what is actually doing it, and then you can kill that command.
Okay.
Now, if you on the Mac, you have Activity Monitor, right?
Mhm.
So it does the same exact thing. So if I were to if I were to run, I can't get to the thing because of, I gotta move this. Go back here. You run Activity Monitor. It's pretty much gonna give you the same thing. You look at CPU, here's your CPU time and threads, etc. You can see there's my Activity Monitor. Right? 8.2, 2.7, it's where it's lying on the, this is ordering it by CPU time. So at its current level, 6.3 to 2.9, so they're off by a little bit. Okay? So in Windows, you have your task manager. It does the same thing. Mac, you have the activity monitor. But if you need to watch what's going on, especially as you're running a piece of code, this is where you want to do it. You also see a number of sleeping processes, right? So these are processes that are running, but they're not doing anything. So they're not taking up memory. So here's my R. My R in here is sleeping. So I probably can shut this down, quit, and it should disappear at some point as it refreshes. Still running. Quit. Why isn't this quitting? So you know what? 1987. So I'm going to kill it. To get out of this, you hit Control C. So I can look for 1987. Here's my R down here. So I basically can say kill 1987. Wait, did I get that right? Where'd it go? There it is. Yeah. And my R is basically gone. Okay? Now, if you get confused on like any one of the commands, there's always, and like I never know all the different parameters. There's a thing called man, which stands for manual. Okay? So let's say I want to take a look at the ls command. I do man ls. I'm going to move this, and it gives me the instructions, okay, for your for the particular command. So you could use any one of these parameters. So like the -A, include the directory entries whose names begin with the dot. If you don't do the -A, you don't necessarily get them. If you want -D, listed directories are listed as plain files, not search recursively. So I could come over. I'm going to get out of this by hitting Q. Whoops, Q. So I could do ls-d. There's no directories there, so I'll come back up, ls-d. Whoops, where am I? You should have it. Why didn't you give me the directories? Okay, and ls. Directories are listed as plain files, not searched searched. Okay, that should have given me the directories. I'll have to see why it didn't. Is there a capital D? Nope. So let's do this. Q ls-ad. Nope, I'm not sure why it's not listing the directories. So go back to that. Anyhow, these are, so the way this works is you have the command and then any set of parameters plus any set of options that are required, file or file, any number of files and so forth. And it will tell you exactly what those commands do. Generally, you don't use a lot other than one or two because they're the most common ones. And there are other commands, which some of them will go over, like df, which is basically the file system. And it tells you how much capacity is used on your system. So I've got 3 meg available, it's 11 meg, so that's not great. Which is 368. Yeah, 368. I'm using 100. I only have 117 available. That's not really nice. Let's see what else for that. I think that's it for this section. Did I skipped something up here? I don't think so. Cat more file permissions and then processes. I'm going to show you this another time when we do like shell programs or run programs. But you can run the program on a command line just by doing program. But if you want it to run in the background, right? So in other words, the operating system will determine if you have 5 things running and you run into the background, it'll give it a little lower priority so that your process, like if you're playing, if you're on Word or Netflix, it gives priority to that. And then as that's sleeping, it'll give you some CPU cycles. And then there's also a way to have it just run without connecting it all to your terminal. It comes right back. The terminal comes right back. You could continue typing, but the process is running totally independent. And that's called with no heads-up display or no hop. So that's pretty much it to start. Does that make sense? Are we okay with that? Do you have any questions? Nobody has any questions? Is anybody still there?
Yep.
I mean,
What did you say, Chris?
Rolling.
I said, I mean, I'm alive.
Okay, well, that's good. Vanessa, what'd you say?
I'm good.
You good?
Uh-huh.
Anyone else?
I'm good.
Okay.
It's going to take a little more, I guess, reviewing this.
Yeah, this is gonna take some practice, which is one of the reasons why I think the videos will work well, but I'm gonna copy this section. I'll copy all of this here. So you have this on the Slack,
All right.
right? Because I think this will help on the Slack. Where is it? Okay, so you have that as an example. Does that make sense?
Yeah. Okay.
Now, I gotta stress. So, if you're going to do this, like for those of you who are taking my class next semester, you wouldn't want to try and get the opportunity to do things in Linux. Okay, you can write your code using RStudio, but then what you want to do is once you know the code works, you run it in Linux. You go to Linux, you go to a directory, you run it in the background, and you let it sit. Okay, because you've got to get used to the change directory, the list, moving up, moving down, copying files, running files. It is the only way to really, really learn this. Okay? Because once you start getting used to it and doing it, it's just like working with any other operating system. Chris, in your case, you're going to have to practice, but the same thing. If you've got your RStudio code that you've written a function, run it on the command line, right? And I'll show you guys, maybe, next time when we run programs, I'll show you how to run an R code in Linux, and I'll show you how to run a piece of Python code as well.
That's
Okay.
cool.
All right.
And then it's really a question of managing things, because, for example, you can manage jobs to run at night. You can manage different scripts, but this is everything that you do on your Mac and Windows where you move files. You should ask yourself, how would I do this in Linux? If I'm moving files, if I'm copying files, if I'm changing directory, because we've gotten so used to using the graphical interface with the drag and drop folders that people don't do a lot of this. And this is really what you need. Okay?
All right.
All right. So then just going down the list again. So Vanessa, you're good, right?
Yep, I'm good.
Gabriella?
Yeah, I know you just mentioned like we got used to the graphic drag and drop thing, but like ultimately sorry, can you repeat why this is the better option? Because it just does seem to take longer.
Okay, so once you have a good piece of code working, you want to run it on a server.
Okay.
And what you want is you want minimal resources on the server for anything not related to doing work.
Okay.
So like when you have your graphical interface, like Windows, it's always waiting to see if a new device was connected. That's why you plug it in and boom, it picks it up, because something is constantly looking. When you have graphics, guess what? That takes a lot of processing, because it's got to draw the nice font, it's got to put things, and that's why some of the processing is on a separate graphics card, because it takes up so much. And that's why even the graphics card is on a GPU chip. It's on a separate chip because it's optimized to do those types of calculations to display things on the screen.
Okay.
Okay.
Got it. Thanks.
Okay. Chris, you good?
I'm good.
Mohammed, you good?
I'm good.
I think that's everybody. Is there anybody else I missed? Alrighty then. All right. Then what I'll do is I'll post this up for you, and then I'll see you guys. Now, I can do another one if you like. There isn't so much dependency, by the way. So it's not like you have to be too dependent. If you want, I can do another one on Friday night if you want, or do you want me to wait until Monday? You don't all have to answer at once.
I could go either way. I have no social life, so Friday's fine with me.
Okay. How about Gabriella and Vanessa? What do you think?
Monday would be better for me.
Okay. Let's do Monday then, because that was our normal schedule. So
Okay.
we'll do Monday, and we'll set that up. If you do have any questions in the interim because you're practicing something, let me know, and then we'll go ahead and do that. Okay? I'll just set up a quick Zoom session for you.